Hey, what's up? It's Jake, and in this video, we are going to finish our definition of parameters and really dig into this before we move on to our next section. So, function parameters can be classified into 5 groups. Okay, you got positional keyword parameters, variable position, variable keyword, position only, and keyword only. So, all the parameters we've seen so far are actually normal position or keyword parameters. We can pass them both at the same time. There's not really a whole lot much more to say, which is why those videos are so short, but there are some other categories. So before I get into that, take a look at this optional parameter. So if I define a function and I say a, b equals 4, c equals 88, we haven't done this before. If I say print a, b, and c, and then I'm going to call function and I'm going to pass 1. Okay, so what this is going to do, it's going to print 1 for, well, let me say the colon, 1 for 88. So what I'm doing here is I'm calling function, but I'm passing the argument 1. And since this isn't defined, it's just going to be like, okay, this a is 1, and it's going to go 1 for 88. But if I call it again, and I passed b equals 5, a equals 7, and c equals 9, what do you think is going to happen? Well, this is going to print 5, 7, 5, 9. So it's going to print them in order, but the whole idea I'm trying to explain here is that if you don't pass anything, it's going to default to these. So these are optional parameters. A is required in this case because it does not have a default value. So A is required, but B has a default value 4, C has a default 88. So if you do need some value in case somebody doesn't put something in, like an input form, and you need a name, address, phone number, etc., you can have parameters with an optional default value. So, anyways, so that's the optional stuff. So let's look at variable positions. So let's say you prefer not to specify the exact number of positional parameters to a function. Well, Python gives you the ability to do this with variable position parameters. So a common case of this is the minimum function. So if you write a function called minimum and I say just star n, what I want to do is I want to print the type for n, and n is a tuple. Okay, is a tuple. So what would that look like? Well, we'll say if there's an n, okay, mn equals n at 0. And then we'll say for value in n1 after that, if the value is less than mn, then mn equals the value. Probably like, what in the heck is he doing? Okay, so, and then I just want to print mn. All right, so in this case, what I'm going to do is I'm going to say minimum 1, 3, -7, and 9. So in this case, n equals 1, 3, -7, 9, and it will print -7 because that's the minimum value. So now that you've seen that, you can see what this does. So I have defined minimum n, and I just pass it however many. So star n, I can just pass it however many I want. Okay, so this is your variable position. So these are positional, but they're variable in that I could add as many as I want, and I can iterate through this. And this is just like one example defining a minimum value, but you could just like create whatever the heck you want. So I'm just going to start at 0 and say for the value in everything after that, if the value is less than 0, then whatever the minimum is, that's my value. And then I'm going to print that out. So hopefully that makes sense. But the idea is, yeah, this is totally variable in length. You can also do something similar with variable keywords. So if I take all this code that we just typed and I delete it, and I define a function that takes keyword arguments, kwargs, and I'm just going to print kwargs and say function, and then I'm going to pass A is 1 and B is 42. Okay, fun. You can't define fun. Okay, so this is just going to print A1 like in a tuple, B 42. Let's take a look at that. So if I just do Python params, so you can see A1 B42. If I were to print no arguments passed, it will just print this empty. If I made 3 of them and I said function A equals 1, B equals 42, C equals 99, you're going to see how it's variable, but they have a keyword assigned to it. So you can do that as well with this keyword arguments. So it's similar to the variable position, but the difference is the syntax. It's got the 2 stars because they are collected in a dictionary is really why. So yeah, hopefully that makes sense. This is useful when doing network connections, by the way, because you can pass parameter options like an IP address, a port, a user, a password, etc. And it's a way to define the input parameters without knowing how many parameters someone's going to pass. So I'm going to just leave it at that. There's a ton of stuff you can do with that one, and go into positional only parameters. So if I define a function A, B, some kind of slash, and then C, and you're gonna be like, what in the heck is that? And then I'm gonna print A, B, C. Okay. Well, if I call this function and pass 1, 2, 3, it's just going to print 1, 2, 3. But if I were to call this function and say 1, 2, C equals 3, what do you think it's going to print? Rinse. It's going to print 1, 2, 3. All right, so let's take a look at this. 1, 2, 3, 1, 2, 3. All right, so we defined a function, specified 3 parameters. We have this slash, right? So in this, what this does in this function is it indicates that A and B must be passed positionally, okay, and not by keyword. Okay, they have to be positionally. So those are positional only parameters. Okay, the last 2 lines show you can call the function passing all 3 positionally. You can pass C by keyword, and that's fine, but if you tried to do the other way around, it wouldn't work. In fact, if you tried to say B equals 2, watch what happens. Got some position only arguments passed as keyword arguments. And if I were to remove this, then what happens? Well, it works just fine. So you just want to make sure if you do, up here, if you do use that, that's what that does, is it says, hey, these are positional only, and then after that, you can do keyword if you want to. You can also do this with keyword arguments. So you could have like a name, which can be which is positional only, and then any keyword argument after that can be whatever. So address, whatever. Yeah. So then let's go over keyword only. So it's going to be very similar. So I'll make this simple. We're going to define a function, keyword only, star A, C. And then I'm just going to print A and C. And if I call KWA and I say 1, 2, 3, C equals 7, what do you think that's going to do? Well, let's take a look. Boom. 1, 2, 3 as an object, 7. So this is how you would say that these are keyword only. So these are my keys, right? These are my keywords, and then this one is going to be explicitly stated. If I only passed one of them, if I said KWO 4, it's not going to have anything in there. And well, this one's just going to say C is 4. It's just going to pass 4 because the first one is empty. So it's kind of, you probably saw this coming, but you can take a variable number of positional parameters A and a keyword only one of C, and the results are pretty straightforward. So let's look at combining the input parameters. So let's delete this and say we're going to define a function and has A, B, C equals 7, star args, and star keyword args. So you can kind of combine all of these, and then you can print them in however way you want. You can print out, oh, I'm going to print out this one, and then I'm going to do this. You can do whatever you want. But yeah, so you can totally mix and match. That's a thing that you can do. Yeah. So I think that's pretty much it. There is one little thing you gotta avoid, little trap. So we'll go over this little trap, and then I think that'll do it for arguments or parameters. So in Python, the default values are created at definition time. So subsequent calls to the same function will possibly behave differently depending on the mutability of their default values. So what does that mean? Okay, so let's define a function, and we'll say that A is an empty list and that B is an empty set of some kind. Okay, so we're gonna print A, and then we're gonna print B, and then I'm gonna print let's see, so times 12, and then we will do a dot append, oops, no space, a dot append. We're going to append our list with the length of A, and then we will do a B dot, and then the list, whatever the length of A is going to be equal to, oh, not dot, B, length of A is going to be equal to the length of A. So this one here affects the default value, and this one affects B's value. Okay. Now what happens if I call this 3 times? If I say function, function, function. Well, let's take a look. Param. What is going on? Okay, so I'm going to print this out 12 times. So first I'm going to print an empty string, and then I'm going to print an empty set, and then I'm going to print this character 12 times, and then I'm going to append the length of A. Okay, so the length of A is 0. Well, it's 1, I guess. And we can see here B length of A equals length of A. So when I call this and it prints A the second time, so this is the first time, 1, 2, 3. Now it's going to say print A. So A is appended, so now it's 0. And then B is the length of A, which is then 1. And then it's going to print this out 12 times, just to help kind of make it easier to read. And the second time, it's going to append this, and now it has 1, because we're appending it, right? We're not replacing it, we're appending it. And then it's going to keep adding values as it goes. And you can see that because there are defaults, and they are mutable, that they are growing, which can affect storage space, database, table space, like all kinds of stuff. So if you affect these objects, any modification will actually stick around in subsequent function calls. So it's kind of interesting. It's handy when using like memorization techniques. So when it happens between the calls, you introduce one that doesn't use defaults. So if I didn't have one with a default, like if I said function in the middle and I said that A equals 1, 2, 3, so I'm not using the default, I'm actually passing something. And then I'll say that B equals set 8, or let's do B as a string, and then the value of 1. Then what happens? Well, I guess let's take a look and find out. Interesting. Different result, because it's not actually um, iterating through that and saving it. So you can see the default values are retained, even if you call the function of other values. But how would you get a fresh empty value every time? Well, this is where you get into something like you would define your function and you'd say a equals none, right? And then you'd say if a is none, then a would be like an empty list, something like that. So if this isn't passed and calling the function, you'd always get a brand new empty list. So hopefully after you've gone through all this input parameter stuff, we can look at the other side of the coin. Since we've been passing everything into our functions, next we're going to go over returning things back from our functions. Have fun.